Okay, let's get into it. So 3.1, Python objects. We're going to talk about objects today because you probably have an intuitive understanding of objects, even if you don't realize it, um, because you've been using them in Python so far. But they're not really in C, so you probably only understand it just intuitively as opposed to actually thinking about it. So, first thing, um, in a programming language like C, you pretty much just have data types, like raw data types, ints, chars, and all of that, and then you have some structs and some lists. But they're all very simple data types. Most other programming languages, right, C++, Java, Python, JavaScript, um, C Sharp, they have this concept of an object, where an object is essentially that a variable isn't necessarily just an int or a char or something, but it's actually this broad object. Think of it like a bucket, where inside of that bucket is a series of variables and then sometimes a series of functions. And it's referred to here as a rich area of software designed with complicated outcomes, because conceptually it's very simple in some ways, and then it can also be very challenging in the implementation of it. A way you might have heard about objects before is in an area around object-oriented programming, which essentially just describes a method of programming where you focus kind of religiously on objects, which if you haven't done much before, it doesn't really matter. We're not doing it in this course. The one place it's kind of taught explicitly is in COMP1531. So you can go and check that out. Someone's asked a question on the chat. They use Java to teach that course. And that is a lot more object-oriented. But the problem is, just because we aren't teaching you object-oriented programming, and just because we aren't trying to enforce or really teach classes, which is a fundamental tenet of it, it doesn't mean that objects don't exist. What it means really is that Python has object-oriented components of it, but you don't have to write those components. You just have to use them. So that's kind of what this lecture is about. It's about understanding objects enough to use them, not to build them. So first thing is that if we have a simple program here, like obj.py, and there's some things we understand from it, right? Like from the datetime module, we're importing the date thing, right? What is that thing? It's actually an object. And there's generally three really important principles of objects. One is you can create instances of those objects, basically kind of like copies of them or new versions of them. You can print variables from them, and you can use functions on them. So if we look at this example here, we import this date thing, and then what we do is we create a date object by doing something like this. And what this is saying is that date is an kind of like some magical object, and I want to create a version of that object called today. And when I create it, I'm giving it a set of parameters. Think of like in your project, right? You have like channel create and channel join and channel messages and stuff. It's like this is kind of like the create part. You're actually creating something here, and in this case, you're saying I'd like to create a date object that is the 26th of the 9th, 2019, and I'd like to store it in the variable called today. So when I print today, I'm actually printing out an object, because basically nearly everything you deal with in Python are going to be objects. And objects will print themselves out in various ways. Sometimes you'll get them print out very weirdly, right? You probably noticed that I'm trying to think if you would have seen one so far. There's some objects that'll print out in super strange ways. In this case, this date today object prints out as just the date itself. The thing about objects, though, is unlike ints, they actually have, as I've said, they actually are basically buckets, where inside those buckets you have variables and you have functions. And we can actually see these here. So you notice that I've got these three lines, 9, 10, and 11, which are particular variables associated with that object, and then lines 14 and 15 are functions associated with that object. And if I run this, the first thing you can see is if I print out the type of today, it tells me that it's some class, right? So if you think about class is just an object template. And then if I print out these attributes today.year, today.month, today.day, it actually prints 2019 9/26. And then if I call these functions on the object, I get the day of the week, which is 3. So the 26th of September was the index 3 day of the week. And then if I print out ctime, which I can't remember quite what that is, I'm pretty sure it's just like get the date as a time. I get Thursday, September 26th at midnight 2019. The point I'm trying to make here, though, is this dot syntax, which, again, you probably have seen before when you're doing something with strings. But it's essentially saying, today's an object, and I want to get a particular property of it, right? So a dot is like get a property. Sometimes that property is a variable. Sometimes it's kind of like a function, if you will. I'm using very broad, simplistic language here to describe something we're not going into much detail about. But it's a property of this. And in Python, dates are objects, strings are objects. Pretty much everything except numbers are objects. It's day 3 because it's indexed, so 0 is Monday, Tuesdays 1, Mondays 0, Tuesdays 1, Wednesdays 2, Thursdays 3. In this case, someone's mentioning this on the chat. We're using the date function in this case because we're only interested in the date. We don't really care about we just don't really care about the time in this case, and that's normal. Sometimes you do things with dates, like date of birth. When you store date of birth, you don't need the time. You don't need to know what time you're born. You just store the date of birth. So just to mention objects, you've dealt with objects before when it comes to strings. In fact, if we go have a look at a Python string, there'd be a ton of resources here. Strings actually have a series of functions and kind of variable properties that you can call on it. And you've probably used these before, right? Or at least maybe 1 or 2 of them in your labs where, Python string capitalized. So in Python, if I create a string called name, this is actually an object, right? It's not a char star. It's not an array of ASCII characters. No doubt there's an array of ASCII characters somewhere in there, but it's a much broader concept. So, in C, a string might be stored again as just like, oh, here's my array of ASCII characters, like A, B, C, D. That is the worst drawing ever. But in Python, it's kind of like, this is your string object. And inside of that, you do actually have the underlying storage where you store those 4 characters, right? Like A, B, C, D. But then you've also maybe got some properties here. And then you've also got some functions over here. And all of this is kind of encapsulated within this object. So these are functions you can call on particular strings. So for instance, if I'd like to, capitalize, converts the first character to a capital letter, I can do that with Python. I can say print name.capitalize like this. And then when I print this program, it'll print out Hayden with a capital H. So this is actually a function that's being called on the string itself. And then similarly, I believe there would be a bunch of string properties, which wouldn't be as interesting if I can find them. This is like the actual Python docs. Yeah, so we got this class string here. And you can see that in the actual Python docs, it shows you, the capitalized function, case fold. It shows you all of those functions that you can call on a string. And I wonder if they're going to give us anything interesting. Probably not. That's okay. Python properties, see if there's any here. A lot of the time you actually use functions on particular strings. So it depends on the particular kind of object you're doing. So the reason we're mentioning this is because students always have questions that are like, what is this dot thing here? Why am I doing a string dot something? And again, another concept you can relate it to is actually structs, right? You're familiar with structs. Structs are essentially if you think of structs like objects where a struct is just a name, but that struct itself has kind of properties in it, and you can access those properties with the dot. So you're like, okay, this struct dot name, this struct dot age, this struct dot height. The only difference with objects that's really key is that objects also have the ability to bind functions to the object. So in this case, we're binding like, you know, a weekday or a C time. So if you, the other way to think about it, as I just mentioned, is to take your understanding of C structs and just expand upon that. You know, and as Milgil says in the chat, same thing, right? Classes are structs with functions in them too. That is a very simple way to look at it, and that's the way we're asking you to look at it. So in Python, objects generally contain what we call attributes, which are the variables in them. Attributes are what we call like .year, .month, .day. So if a variable is part of an object, we tend to call it like an attribute. And if there's a function in an object, we tend to call it a method. So these terms will be used interchangeably. Sometimes you'll hear, oh, the object function, that's the same thing as an object method. You might hear like an object property or an object variable or an object attribute. They're all used interchangeably as well. And that's kind of all there is to objects. You just need to know that it kind of exists. Now, I mentioned this before, that virtually everything in Python is an object. That is true. So for instance, lists are objects, dictionaries are objects, tuples are objects, strings are objects, dates are objects. I'm pretty sure the only thing, and I don't even think that's true. I think even numbers are objects as well. So if I say I equals 1 and then I print the type of I get, yeah, so it's actually an object itself. And what that means is that Python integer methods, for instance, if I Google this, this large file kills me. I see there's float types, string types, byte types. Probably should have just looked in the glossary at the top, wherever it is. Numeric types, yep. Yeah, so you can see like even basic integers have these. I mean, I never really use any of these, so I'm not too familiar with it. But like bit length, like let's try printing this out. Let's try printing i.bit length. See if this works. 1. Right? So like even an integer is not just like 4 or 8 bytes. It's actually an entire object, which is this whole like, you know, big circular thing here, where it includes like some functions and properties and the actual underlying data. And that's interesting because you can see bit length here is basically how many bits do I need to store that number. So if I have 1, it's 1 bit, and if I do something like 16, it's going to be 5 bits, right? Because to store 16, you need like 1, 2, 4, 8. Yeah, you need like, that's 10000 in binary, right? So you actually need 5 bits to store that. So there's lots of cool things you can do with objects. Objects make it a lot easier to work with because there's so much power to them. They do, of course, make things slower, and that's why languages like Python are a little bit slower than languages like C. This is not really that much a part of the course. We have I think 1 or 2 very simple lab questions on it in this course. So we're just going to touch on this briefly, but it's not expected that you do it for your labs generally. We don't expect students to do this for the major project. And the reason we don't expect people to make their own objects is because it's a bit of a can of worms, right? Like we're going to give you a simple example today, but that leads to like 5 questions. Then the answering of those questions leads to like 5 more questions. That's why sometimes there's entire courses just on these concepts. But we'll keep things pretty simple today. So let's actually create our own object, right? So we've seen that integers an object, strings an object, date times an object. There are lots of objects in Python, but we want to make our own. And that object is called student.py. Now, everything lines 1 to 11 is me defining my object, a little bit like defining a function or defining a struct. I'm defining I'm giving a definition for use. And then down here, I'm actually using my objects. I'm actually creating a version of it. So again, you know, like in C, you can define a struct, which is a template, and then you can create many instances of that struct. It's a similar thing here where we can create an object and then create many instances of that object. So the way this works is that a class in pretty much any language is an object template. It defines, it is the type that describes how to create an object. So technically here, this is a class definition, and down here we are creating an object called Rob, which is of class type student. So class being the template, and then when we actually create something with that template, it's what we'll call an object. And generally speaking, we mentioned that objects have properties, attributes, or variables, and then they also have methods or functions. The only special part of classes or objects that we're going to talk about today is this magical function called an init method. And this is basically a function that's called when you create an object. Right, so this class is called student here. So if I want to create a student, and maybe I'll keep this even simpler. I'll leave that for now. If I want to create a student, let's keep it simple. If I want to create a student, I could do something like this. Hayden equals student. Print Hayden. Now this really simple Python file, this really simple Python file follows a pretty straightforward syntax. Class student means we're going to create our own type, which is an object-ish type called student. And what we're saying is within that object, the only thing that exists is a function called email address, where when I call that function, what it does is it returns me this string. So then my use of it is actually I say, well, this is my class type here, student. I'd like to create an instance of that class type called Hayden. So Hayden is now an object of type student. And in fact, you can see that if I print out the type of Hayden here. It says its type is class student. And then what I can do is, because Hayden's an object and objects have methods and attributes, I can call the function on it called email address, which will return me with a particular value. So that's like a really simple thing. We can also add properties to our object. So for instance, I could say age equals 18 or something like this, where I could print age, or I could print Hayden.age. So you see, now I'm printing this kind of like it's a variable, right? So I'm not calling a function, I'm calling like a property of the object, right? So again, it's a little bit like a struct with functions. So here, class student is a struct. It has a property age 18, and it has a function called email address, which I can use to call. Now, if we go back to our earlier example in a sec, one thing that happens is that when you're creating an object, sometimes you want to be able to set parameters on it, right? And we'll get to the self, like I know you guys have questions. We can't answer all the questions today. But you actually want to be able to change what's inside of the object. Now, one area that objects differ a little bit from, I guess, structs is that with objects, or there's actually a whole bunch of stuff inside the class or object itself that shares data. And what I mean by that is I might make another function here called setName. And inside of that, what I want to say is that I want to be able to set a certain name to be to the email address. Now let me just write this example out and we can talk about it. So here I'm going to say self name equals new name. I'll make this an F string, and inside of here I'll put self.name. Okay, so let's have a chat about what this is and why it works. Let's just run this. So inside of a class or an object, self refers to the object itself. It's a little bit of a strange concept, but basically self is the actual whole object. It's all of the methods, it's all of the functions, it's all of the variables and everything else In this case, when I say self.name, that's a little bit different from saying name equals new name. If I say name equals new name, what I'm essentially saying here is that the local variable name inside of my function is equal to new name. And what that means is that if I come down here and I try and print name, Python will be like, I don't know what name is, because these are both local variables inside the function. Right? So this name here is a local variable. This name here is a local variable. Python says name is not defined. It's like, well, that's not a variable. This becomes problematic because what happens when we want to be able to share data around an object, where I want to be able to set a name within an object and then actually use it later. So what happens is if I use the self prefix, I'm essentially saying, okay, name, I'm assigning it to the actual object itself. So it's kind of existing outside of the function. The way we normally talk about this in other courses is we talk about scope, where like you're used to having a global scope and then a local scope, right? Where a global scope is your entire program and a local scope's inside your function. Whereas in the middle here, we kind of have this object or class scope where you can have a variable that doesn't exist in the global scope, right? It's not quite global, but it's also not quite like a local function, not quite a local variable inside of a function. It exists inside the whole object. So what actually happens here is when I call this function setName, it sets a variable called name on the actual whole object. And that means everything in the object can access it, which is why when I call email address after, I can actually like use something that I defined in another function, right? So I create a new object, which is kind of like creating a new struct. I call a function on that object called setName where I give it a string Hayden. It takes in that name. It sets that variable on the whole object itself. And then when I call Hayden.emailaddress, that other function still inside my object or class is able to use it. And that's how I can get something printed out like that. So just before I finish off this example, are there any kind of lingering questions about just what we've done here? And as I said, self refers to the actual object itself. It's think of it like a global. Think of it like a way to make a variable global, but just inside the class or object. Claude says, "Sorry, I was a bit lost. Is the current output from code without self.xxx?" I'm not sure what you mean, Claude. Sorry. Joanna says, what happens when you print the email without setting a name? That's a great question. So Python will actually crap its pants and it'll be like, sorry, but like the student object has no variable called name because we didn't set it. We can also fix this by giving it like a default property like name equals blank or something. So if you define a variable kind of inside of like a class or object, it basically exists within that whole object. So you see when I run this one now, got to fix that indenting. You can see that this now works. So it's kind of like the default value for the object variable name or the object attribute name is blank, and then set name will actually kind of override that. We don't need to put self.name here because it's kind of already outside of a function. The only reason self exists here is to distinguish between a local function variable name and a like object scoped variable name. Tenet says, can't we just create a name inside the class, but outside the two functions? Yeah, we can, but this way it's more dynamic. Like this way we could actually do something like we could set the name to Hayden and then set the name to Michael and print it out, you know, two different ways. And then Kirishan says, can we call functions without the object prefix? No, so that's the main difference. So basically there's kind of two types of functions. There's what you'd call global functions, which are like functions out in the global scope, like this. And then there's kind of object functions which only exist inside of objects themselves. So if I was to just, for instance, call just set name, this function does not exist in the global scope. It just doesn't exist. It only exists within inside the class itself. It's a little bit like how, you know, in the datetime library, there might be like a function called string ptime. But this doesn't exist unless I actually qualify it by saying, like, I'm going to import datetime, and then it's inside the datetime module. So without kind of doing the Hayden.setName, it's like setName just doesn't exist because it only exists within inside that student type. So Miguel kind of, yeah, I mean, Miguel's answered a question like this, but the reason we like these class things is because it allows us to make multiple of them. So for instance, here I could make another type called Michael. I might use like my full name here, right? Call him Michael Johns or something. You can actually make many objects of the same type. So in this case, I'm making one object called Hayden, which is of type student, and then I'm making another object called Michael, which is of type student. So now we have two objects in Python. It's a little bit like the string type is just one type, but you can create many strings of it. So here we can create many objects of the same type. Panda says, so if we declare a variable outside the functions in the class, does the need for self disappear? Yeah, so if you define like a variable here, like name equals blank, what you're doing is you're saying it's inside the class, right? If you define it up here, it's like it's global. If you define it in the function, it's a local variable. And if you define it here, it's actually kind of part of the class. Camilla says, I'm confused why we can't run new name as an input to set name when we haven't defined it yet. I don't know if I'm understanding you correctly, but new name is just a function parameter. So it's nothing special. Which leads to kind of the last question here, which is, what the hell is self? Right? And what self is self is actually, like why, sorry, not what the hell is self. Why do you have to pass self into every function? And the reason for that is basically, it's just what you do. Every function you define in like a Python class, you put self as the first argument, and that's how you can do things like this. Because if you don't have self here, what actually happens is that Python kind of craps its pants. It's like, so generally, if you're doing stuff inside of a class, your first parameter should always be self. So for instance, if email address is normally a function that takes in no parameters and prints something out, instead of it having 0 parameters, it now just has 1. And in this function here, which would normally have 1 parameter, instead of having 1 parameter, it now has 2. I'm going to answer some last few questions here, which is like, so Fang Yu says, when we use a function from that library such as string.replace, why do we put the name of the string in the first and the function after the dot? Isn't it an object, so we put the object first? I don't understand your question, I'm sorry. Yep, and then Claude says, so if we compare it to C, is class like a struct? And Hayden student is like a struct named Hayden. Yeah, exactly. So like if this was C, you might have something like struct student, which has like, you know, char star name. But there are no functions, which is really sad. Very sad. And then after that, you might say, you know, struct student Hayden, Hayden.name equals Hayden Smith. I'm just being really rough here. You know, printf, you get the point, Hayden.name. And then you do the same thing for Michael, right? Similar kind of thing. It's just you have the power of functions here. So, like, I don't like this lecture very much, right? And I don't mean, yeah, so many missing semicolons. I don't like this lecture much, and what I mean by that is not that I hate the slides or that I think it's poorly explained. What I hate is that if we don't teach classes, there's enough students who know it that they start telling all their friends about it, and their friends think they're missing out on something really critical. And also there's examples of this all over the internet. And fundamentally, it's useful to understand classes because this is how objects are made. For the strings, the date, times, integers, all of them exist somewhere in Python. All of these exist somewhere in Python as a class. And when you create a number, when you create a string, when you create a date time, you're just creating instances of these classes. The problem is, though, with teaching it is that if I was to try and teach classes properly to you and explain like what self is and then all these other aspects of classes and the object model, I'd probably want to spend maybe 8 hours, like maybe 2 weeks of lectures on it. And we don't have 2 weeks of lectures in this course. So what I'm asking, I guess, from you all is that the point of this lecture is to explain what objects are, that everything in Python is basically something with functions and attributes, and it's more complicated than just a 4-byte integer, and that how they're created is using these things called classes, which you can go and play around with, and we give you a couple of simple lab exercises on it. But fundamentally, I'd probably encourage most of you to just not try and actually integrate this anywhere into the project or anything like that, because it's gonna lead to more questions and more questions and more questions. But if you'd like to kind of tackle it and teach yourself some stuff and your group is happy with it, then please go for it, because it's an interesting thing to learn. Fangyu says, so if we call an object, we use student.setName, right? The object student is in front, but if we call a function, we use string.replace. The replace is after the dot. I don't fully understand your question, because as Joel says, replaces the function. Replaces the function. And as Griffin has kind of said, it's kind of like, just to put Griffin's code here, it's like object function, right? That's what we're doing here. Like Hayden is an object, Michael is an object, name, these are the structs. Hayden is an object, Michael is an object, and then, set name or email address. These are all attributes or methods of particular objects or classes. And I kind of agree with Miguel that, like, for the project, it's probably easier just to stick with dictionaries for the most part. Camilla says, instead of self, could we use the class name? Maybe. I can't even remember. I could try it out, but generally we just want to use self, mainly because it's convention. So this is kind of always self. That's what you'd see if you look up other examples. Sarth says, is dictionary an object? Yeah, dictionary is an object. Everything in Python is pretty much an object. Dictionaries, lists, tuples, strings, date times, everything like that. So you can kind of go and play around with this if you want. I'm not going to go through this example fully and talk about what this function is, because it's actually really not necessary. And if you want, you can kind of learn it in your own time. So I really don't want to spend 10 minutes on that, because I don't think it has any fundamental educational value to this course. But that's pretty much classes. You can store attributes on them. You can create functions on them. Pretty straightforward. And yeah, so this is from an old slide, which was before we added another topic. Which I really should change this one. I'm sorry about that. But basically there's change it. It's the file works. There's a CSV file, which is part of one of your labs, where there's a bunch of weather data. And you'll see this in one of your labs. Normally we'd maybe go through this in the lecture with a bit of an example, but there's a whole bunch of weather data from the Bureau of Meteorology that is kind of fun to process with Python. But there's a lab exercise on that now instead of it being in the lecture, so you can take a look at that. So maybe like an interesting answer to a good question which was just asked is kind of, to paraphrase it, is it true that everything is an object in Python, but is Python not object oriented? So the short answer here is that In a true object-oriented language, you actually can't do anything but create classes, right? So all you can have is classes. So this stuff up here is kind of object-oriented style programming. And this stuff down here is what we would call, I don't know, somewhere between imperative programming and scripting, right? Like in Python, you can just say 2 lines, Hayden, name equals Hayden, print name, and it will print Hayden. Python is a bit of a hybrid. So Python has object-oriented components, as in like you can use classes in it, but you're not required to use classes for everything. And that's where a language like Java, which you'll learn about in another course, differs. Is that Java is basically everything has to be objects, is the short story. So this is not, you wouldn't call Python an object-oriented language in the strict sense of the word. I would call it a scripting language that is, has object-oriented capabilities. Cool. They were just a couple of extra slides. This year I decided to go a little bit more into explaining what classes were and skip over this init function because I don't think that's as necessary as talking a bit more through the self stuff and other things. But hopefully this makes sense as to what's actually powering it. So remember, out there in the Python library, there is like, class string, there's like class date time, there's like, all these types you use are built as these classes. So hopefully that gives some more context on it. Any other questions? Otherwise, we'll take an early break and then jump into the next lecture. Yeah, break, please. That I understand. I understand we've been talking for 50 minutes. Extensive. All right, well, if there are no questions, let's take a 5-minute break, and while we have the break, let's come back at 1:01 p.m. Go stand up, walk around, drink some water. In the meantime, if you could just answer the poll for this one, that'd be great. So that's pretty much it for Python objects.